Hey viewers, welcome back to our YouTube channel. Hope you are doing extremely well. So today we are going to discuss a problem statement, that is remove duplicates in a sorted linked list. So before moving to that problem, if you guys are new to our YouTube channel, then please do consider subscribing to our YouTube channel. So let's discuss the problem. So in this question, we are provided with a sorted linked list and we need to remove all those nodes which have the repeated data. And we need to perform this operation in order of 1 space complexity and order of n time complexity. So it's my request that you try to solve it by yourself, and after that we discuss its solution. So I hope you have tried it by yourself. Let's discuss its solution. So in this question we are provided with a sorted linked list. Let's create it. 1 1 2 2 3 3 4 4 5. This is nothing but the this linked list, means the linked list on which the call has been done. So just to solve that problem, what I will do, I will create a new linked list, that is the res linked list. And what I'll do, I will perform the remove first operation in the provided linked list. Remove first is nothing but remove the first node from the beginning of the linked list, and it is of order of 1 time complexity operation. Just because here we are doing nothing, we are just incrementing the head. So it remove that node from here. So what to do? We add that remove node in our resultant linked list here. Okay. Again, we do the same. Remove that node from the provided linked list, but this time we don't add it to a resultant linked list. Why? Just because the data of the tail of the resultant linked list is same as the data of the remove node. So as the data are same, we just discard that node. We discard it. Now again we perform the same operation. We remove that node from the beginning of the provided linked list. This time again we add it to our resultant linked list. We add it just because the data of the tail of the resultant linked list is not same as the data of the remove node. Okay, so I hope you are getting the basic intuition behind that problem. The intuition is that we keep on removing the nodes from the provided linked list, but whether we will add it to a resultant linked list or not, it is depends on some condition. Okay, what will those conditions? Those conditions will be nothing but we add it to a resultant linked list only if the resultant linked list size is 0, or the data of the tail of the resultant linked list is not same as the data of the remove node. Okay, I hope you get it. So let's complete this dry run, and after that we code it. Okay, so again we remove that node, but this time we don't add it to a resultant linked list just because the data are same. Again we remove that node from the linked list, but this time we add it to a resultant linked list. Again we remove that node. This time we don't add it just because the data of the tail of the resultant linked list is same as the data of the remove node. Again we remove first from the provided linked list. We add last to our resultant linked list. Again we perform remove first from on our provided linked list, but this time we don't perform add last to our resultant linked list just because the data are same. At last, for the last node we perform the same, remove first, but this time we perform add last. Okay, so eventually at the resultant linked list we get our desired output. Okay, now one more thing is that at the last we need to update this pointer with the properties of the resultant linked list. Why we need to update this pointer with the properties of the resultant linked list? Just because eventually we get our desired output in the resultant linked list. Okay, we need to tell somehow to the main function that yeah, we have performed this operation and we just want to print it just to pass all our test cases. Okay, but when you can see to the portal, you can see that the function in which we need to write the code is of void type. Means how we will tell the compiler that yeah, we have performed the operation. So we'll tell it by updating the this pointer. Okay, and one more thing is that eventually at the end this pointer size is 0, means the node which it was pointing is deleted, like we have removed all of its node. So what we'll do, we just update this pointer with this resultant linked list. So let's try to code it, and after that we will analyze its complexities. So we will write the code on the pep coding portal. So here at the first step was creating a linked list. So we created a list, linked list res new linked list. Okay, now we need to keep on iterating over the provided linked list. So we iterate it. while this dot size is greater than 0. While iterating, at first what we need to do, we just need to remove that first node from the provided linked list. So before removing, let me get the data. This dot get first. After getting the data, let me remove that node. Remove first. Okay. Now we have removed that node from the provided linked list. Whether I will add it to my resultant linked list or not, it depends on some condition. Let's write those condition. We add it to a resultant linked list only if the resultant linked list size is 0 or resultant.tail.data is not equals to the value. Okay, so in that condition we add this to our resultant linked list, add last value. Okay, at the last means when we have only iterated over our provided linked list, and our provided linked list all of its nodes are perfectly removed, then what we do, we just update this pointer with the resultant linked list pointers. Means the properties of this pointer with the properties of the resultant linked list. Means this dot head will start pointing to the resultant dot head. This dot tail get updated with the resultant dot tail. Okay, tail. Resultant dot tail. Let me update it. And this dot size will be nothing but resultant dot size. Okay, one more thing let me I want to tell you right now is that most of the interviewers, teachers, and even the students don't expect to write the code like this, but we believe that why not to write the code by using the help of the OOPS concept. Like we have already implemented the functions like remove first, add last, add first. If we don't use those functions right now, if we start working on tweaking the nodes, then it will do nothing but make our code more messy and more complicated to the reader. And as you can see that it is very neat and clean code, and even the noob programmer can read it very easily. Okay, so that's why we are writing our code by using the OOPS concept. So let's try to run it. So it get accepted. Let's try to submit it. So yeah, it is correct. Okay, let's try to analyze it. Okay, so let me take this whole code to my current page. Let me erase this. Okay, so here you can see that first thing is the time complexity. Okay, the first thing is the time complexity. Okay, so here you can see we are iterating over the provided linked list, so it will be nothing but order of the size of the linked list. I'm assuming that it has n nodes, so it will be order of n. As I told you earlier, that get first is nothing but is order of 1 time complexity function. Similarly, the remove first is nothing but is of order of 1 time complexity function. Similarly, the add last, it is nothing but order of 1 time complexity function. So you can see it is of order of 1, it is of order of 1, and it is of order of 1. So means we are performing 3 order of 1 time complexity functions within order of n time complexity loop. Okay, so when you add it, it will be nothing but of order of n time complexity. Here you can see our time complexity is order of n. Okay, it is easy. Let's try to figure out how it is order of 1 space complexity. Okay, and it is fun to check that how it is order of 1 space complexity. You might be thinking like, here I have created a new linked list, then and you are saying that we have order of 1 space complexity. You might be thinking about it, but what if I tell you I have not created a new linked list, I have just created an object. As you can see, linked list is a class and resultant is an object. Okay, I have created a resultant object, the object of the linked list class. So how many size of data the resultant linked list is holding? It is holding nothing but the head, the tail, and the size. it has the memory of for all these three properties. Means I have created an object which have these three properties. Then you might be thinking that we are adding nodes to this linked list. No, we are not adding nodes to this resultant linked list. We are means we are adding the nodes to this resultant linked list only after removing that node from our provided linked list. Means a node at a particular instant of time are either remain in a provided linked list or either in a resultant linked list. It can't uh, it can't exist in both of these linked lists at the same time. Okay, you can see here at first we are removing that node, and after that, based on some condition, we are actually adding that node. Okay, so that's why it is of order of one space complexity, as we are not creating the whole linked list again. We are just creating an object, and this object will be nothing, will not taking the size of the whole linked list. It is just taking the size of these three properties. Okay, I hope you get it. So I hope you get it that how this concept is of order of one space complexity, how this concept is of order of n time complexity. One more doubt that most of the student encounter during working is that why, as we are updating the head here, why don't we write something like this equals to result? Why don't we write like this? Why we need to update each property individually? We need to write this, and this is wrong just because this is read only. Okay, we can't update this. Okay, we just update the properties of this. I hope you get it. So if you like this video, don't forget to hit the like button, and please subscribe the YouTube channel, share this video with your friends. Till then, stay safe, stay healthy.